guys, I'm super excited to share with you what we've worked on for this Chainlink Hackathon. In this video I'm going to show you how we're using the Chainlink Oracle features in order to report on the outcome of a football match and use that outcome to make a fully decentralized prediction market. So without further ado, let me show you how it works. Is deploying one of the smart contracts. The smart contract in this instance represents a market which users can come and bet on. So each of these markets will represent a single football match. So let's go and deploy one now. So we've now got a list of upcoming football matches in the Premier League. So we're actually not going to pick any of these, and I'm going to put in a test match. So the problem with the matches there is that they're all happening in the future, so I can't show you how it works. So this match here is one that's happened yesterday. So let's say we'll fund the market with $250 to begin with. So we'll just wait for the transactions to get sent. Perfect, so that's all done. We've created that market. Let's see how people can interact with the market. So let's run a different script now. So you can see here that the contract is offering me a quote to buy outcomes on either the home team winning, the away team winning, or the final outcome being a draw. Now in this match I know that Liverpool wins, so that's the home team. So let's put a bet on for Liverpool to win. So let's say the home team. And how many outcome tokens do we want to buy? So an outcome token pays 1 die if you're correct. So let's buy 25 die, 25 tokens. So that will pay out 25 die if we're correct. Awesome. So now that you can see that I've bought some outcome tokens on Liverpool winning, it's now adjusted the prices of the other outcomes. So that's one of the quite cool features of this market maker. It says the outcome is 0. So in this instance, it means that the contract doesn't know what the outcome of the match is yet. So let's say that now that the match is finished, how are we going to find out the outcome? Well, this is where Chainlink comes in. So now let's run this other script. And now what we're going to do here with this function is we're going to send a message to Chainlink asking it to find out the outcome. And it seems like it's reverted. I know why. I need to give it some Chainlink tokens. So let's see if that, let's just do that. Oops. Send 5 tokens. Confirm. And now let's run this again. So now this time it should go through. Awesome. So now let's see what's going to happen. Well, this is happening. I'm running one of my own, running a Chainlink node. And you can see here that it will pick up the job. There we go, 1 minute ago. That job looks like it came through successfully. So now let's go back to our contracts and see what happens here. And you can see here that it said the outcome is 1. So that means the home team is 1. And it's got that information straight from Chainlink. How cool is that? Behind the scenes, there's quite a lot going on in the smart contracts, and I'd be super excited to show you how they're working. So the main contract is this LMSR contract, which is how the smart contract generates the prices for each of the bets. So this is a type of automated market maker that utilizes a conditional tokens framework. So this one is a liquidity-sensitive logarithmic market scoring rule. The benefit of this sort of algorithm is that it can generate profits for liquidity providers. So we hope to build a platform similar to how Uniswap can give profits to its liquidity providers. That Chainlink provides us is its feature of external adapters. So in order to get the outcome of a football match, we're making an API call to a football API in order to get the outcome of the match. Now, rather than just making the call to a single API, what we're able to do with the external adapter is we're actually able to query two different APIs and check that they both agree with each other in order to ensure that a malicious API actor cannot influence the outcome of these markets. In this setup that we've got, we're only looking at two APIs and we're confirming the results between two of them. But there's no reason why this can't be expanded to include 3 or even 4 or 5 APIs in order to get a truly decentralized outcome reporting system that can be used to feed into prediction markets.